Welcome everyone to lecture 1 of Sedimentology, and in this series we are going to follow the book by Gary Nichols. And just to give you an introduction about what sedimentology is, well, in sedimentology we study the processes of the formation, transportation and deposition of the material, that is the sediment, in various environments to form the sedimentary rock. So basically, like how these sediments come and how these sediments get lithified to form these rocks. We're going to study in these. So starting with classification of sediments, sedimentary rocks. Here comes the first flowchart. This flowchart ke through we can easily see that sedimentary rocks are of two types, clastic and non-clastic. And further, there are subclasses, the volcanoclastic, terrigenous clastic, carbonates, evaporites, and some other sedimentary rocks. So firstly, we are going to start with terrigenous clastic. Terrigenous clastic में क्या है? The word clastic we need to know. So basically, these are classed. Classed means the particles which are derived from the pre-existing rock. एक कोई existing rock है, उसकी weathering हो गई या वो टूट गया. So the particles that come out are known as clast. These clasts will transport and get deposited to form the clastic sedimentary rocks. Now, since these clasts are of detritus eroded from the bedrock, so इनको detrital sediments भी बोला जाता है. And since they are made up of silicate minerals, इनको siliciclastic sediments भी बोला जाता है. Now, we know कि सब एक ही same size के तो होंगे नहीं. So clast will be ranging in size. So there will be clay particles which will be in microns to boulders which will come in meters. Okay. And sandstone, conglomerates and mud rocks. These three are the terrigenous clastic sedimentary rocks in which sandstone and conglomerates जो है वो 20 to 25% बनाते हैं total sedimentary rocks का in the stratigraphic record, and mud rocks make up about 60% of the sedimentary rocks. Next we have is the carbonates. When we are talking about carbonates, we know it is limestone. Limestone is basically a rock which will contain 50% of the calcium carbonate. How do we get this calcium carbonate? So basically calcium carbonate किसी natural environment we get it from the hard parts of the organisms, which are mainly the invertebrates such as the mollusks. Invertebrates are the organisms which are in soft body parts and they have a hard outer shell. So this shell which they have is made up of calcium carbonate, and this calcium carbonate helps us to get the limestone, which is a sedimentary rock with 50% calcium carbonate. And limestones basically constitute 10 to 15% of the sedimentary rocks. Earlier, sandstone and conglomerates were making about 20 to 25% and mud rock 60%. Next, we have limestone which make 10 to 15% of the sedimentary rocks. Next comes is the evaporites. Evaporites are basically the deposits which are formed out of the precipitation of the salts. Precipitation of the salts from the water. Now, if there is a salty water, it will undergo evaporation, and when after evaporation सिर्फ salts रह जाते हैं. So these salts are the precipitate which we call as the evaporites. Then we have the volcaniclastic. Volcaniclastic sediments are again the sediments which are products of the volcanic eruptions. Volcanic eruptions say we get the products which help us in forming of the volcaniclastics, which are the volcaniclastic sediments, and via these we get the sedimentary rocks, the volcaniclastic sedimentary rocks. And there are other sedimentary rocks also, like ironstone, phosphate sediments, organic deposits like coal, shale, chert, but ये सब बहुत ही common नहीं होते हैं. They are very less common, and so they make up about only 5% of the stratigraphic record. So ये बहुत ही कम है. And just like how we saw that limestone was 10 to 15%, sandstone conglomerate 20 to 25%, mud rock 60%. These are only 5% of out of the total sedimentary rocks. This is like just the introduction of these types of sediments. Now we'll study in detail about the types and the rocks they are forming. So basically in this lecture I'll just cover about the terragenous clastic sediments and just an introduction, and then we'll go to the different rocks that are being moved. So initially we have the loose aggregates. Loose aggregates means the mud, silt and sand. All these will be known as the loose aggregates. And job we are adding the suffix stone with it, that is mud stone, silt stone, sandstone, we are indicating that now the material, this loose aggregates have been lithified and now they are a solid rock. So we are writing mud stone, silt stone. Okay. Similarly, there are coarse, loose gravel material which are named as granule, pebble, cobble, and boulder. These, when lithified, become the conglomerate rock. Okay, these are making their individual mudstone, sandstone, siltstone. But if we are having these coarse pebbles, cobbles, and boulders, they come together or they turn into a rock which is known as conglomerate. Now here we need to know that terragenous clastic sediments, there is a threefold classification. Classification on the basis of their grain size. So gravel and conglomerate basically consist of clasts which are greater than 2 mm in diameter. Then there are sand size grains which are between 2 mm to 1 by 16 mm or 63 microns. And then there is mud, including the clay and silt, which is made up of particles less than 63. This is micrometer, not mm. This is micrometer. Okay, so less than 63 micrometer in diameter. Next we have is the wooden Wentworth grain size scale. Here we need to know the four basic divisions, that is clay, which will be less than 4 micrometer, silt, which will be between 4 micrometer to 63 micrometers, sand, which will be 63 micrometer to 2 mm, and gravel aggregates, which will be greater than 2 mm. As you can see this in the scale. From here we can see that the clay particles are basically making up about they're like less than 4 micrometers in size. Then as we go up we have silt over here that makes from 4 micrometer to 63 micrometer, and then we have sand which is making up this part, that is 63 micrometers to the 2 mm in scale, and then we have this whole as gravel which is making greater than 2 mm